Shout out to Rhett Writing of Class 2B. Alright, Rhett. Here we go. So here's where we left off. Okay, this idea right here. If you have a negative number and you're going to multiply it an even amount of times, your result is always going to be positive. If you have an even number of negatives and you multiply them, your answer is always going to be positive. If you have an odd number of negatives, if I got 7 negatives and I multiply them, my answer will always be negative. So if I have 37 negatives and I multiply them all together, negative times negative is a positive, your answer is going to be negative. If you have an even amount of negatives, your result will always be positive. So, then we introduce this guy right here. I have an odd amount and my answer is negative. That, Carlos, that's real. If you have an odd amount of numbers and your result is negative, that is real. If I've got 5 of them and my result is negative, that can happen. That is real. Here's the problem. If I have an even amount and my answer has to be negative, that introduces a sticky scenario. This is not real. I've got an even amount of something and my answer has to be negative. That is not real. Because I can only produce negatives if I have an odd amount of them. So, here we go. Gracie, we went through all these equations. We introduced naturals, rationals, integers, wholes. This is the problem where we get hung up on. This guy right here. Let's walk through this. Okay, let's look at side by side. Let's look at 4x squared equals 16 versus a negative 4x squared equals 16. So we're going to solve for x. We got to figure out what value we can put in for x to make this true. So let's do the 4x squared equals 16. Okay, we're going to solve for x. Undo the multiplication. So we're going to divide this by 4. We're going to divide this by 4. 4 divided by 4 is just 1x squared, and 16 divided by 4 is 4. Now we've got an exponent of 2. That means there's going to be 2 solutions. X is going to have 2 values. If your exponent was 3, you would have 3 solutions. If it was 4, you'd have 4 solutions. If it was 1, you just have 1 solution. So my exponent is 2. I'm going to have 2 solutions. You undo a square. The inverse of a square is a square root. So I'm going to square root that, and the square root undoes the square, so we just have x. And I got to square root both sides. What is the square root of 4? So x equals 2, or what is my second solution? 2 or negative 2. Because 2 times 2 will result in the 4 I need, and so will negative 2. Negative 2 times by negative 2 will also result in the 4 I need. So, Jackson, if you ever take the square root of something, it's going to be, give me both roots, plus or minus 2. A positive 2 is going to work, a negative 2 is going to work. So give me both roots. Now, let's go over here. So Brooke, same thing. Let's undo this multiplication. Let's divide by negative 4. Let's divide by negative 4. And negative 4 divided by negative 4 is 1. So we got 1x squared. But 16 divided by a negative 4 is a negative 4. And I'm setting you up for failure. Because look, I need to have an even amount of them. But my outcome's got to be negative. A negative times a negative, 2 of them, is always going to result in a positive. So this is not real. Undo the square. Square root, square root. And the square root undoes the square, so we got x And then it just took a square root, so I need both. The plus and minus. Square root of 4 is 2, but square root of a negative is imaginary. So we introduce imaginary set of numbers. Now, if we take two imaginaries times two imaginaries, the 2 times the 2 will give us the 4. And do you remember what the imaginary times an imaginary gives us? It creates a negative. And 4 times a negative 1 is a negative 4. And if I do the negative, if I do a negative 2 imaginary times negative 2 imaginary, negative 2 times negative 2 produces the 4. And the imaginary times the imaginary creates a negative real. And 4 times negative 1 is a negative 4. So they both give me negative 4. Okay, now let's skip. Here we go. We're going to introduce the complex numbers. So all of these are shorthand. So if we ever, and they all have like these 2 bars going through them. So n, that introduces the set of naturals. W, if you ever see just a shorthand W with 2 bars, that's talking about the wholes. Z, if you gotta guess Z, Z introduces what? Who said it? Integers. Okay, integers. And Z is really weird. Z is like the German word for integer starts with a Z. So we use Z because the German guy, he give him credit. Okay, Q. Q makes sense. W makes sense. N makes sense. Q is quotient. So quotient is like a answer of a division. So these are the rationals. So they can be written as quotients. So like 10 divided by 2, 10 divided by 4, 10 divided by 6. So if they can be expressed as a fraction, they're rational. Okay, this one maybe doesn't make sense. The Q bar, the bar over it. This is going to introduce the irrationals. Dylan? The R is, you got to guess what you guess. Good guess. Real. And then the C. The C is complex. So C is going to be complex. Okay, so now, oh man, my pad's not working. It's bad news. Okay, here we go. I'm going to give you a string of numbers. I got a bunch of numbers right here. So this will help us make sense of what kind of numbers are what. We got this one right here. Oh man, it's not working at all. Okay, 3i is imaginary. So right below it, let's go. This is imaginary. There we go. Okay, it's imaginary and it is complex. Square root of 10. Carlos. Square root of 10 is right in between this. It's It's right in between square root of 9 and square root of 16. What do we know square root of 9 is? What about square root of 16? Square root of 16 is 4. So if you got to guess like a value of square root of 10, what is your guess? It's in between 3. It's really closer to 3 than it is to 4. So 3 point something. Oh, blah, 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 blah. Now, square root of 10. What kind of a number is square root of 10? It is irrational. What else is it? It is, if it's irrational, it has to be real. And now, we're saying it is also complex. Every number is complex. Okay, now let's look at this third one. We've got 4 reals minus 7 imaginaries. So we got some reals and we got some imaginaries. So if you got to guess how to classify this, 4 reals and minus 7 imaginaries, Carlos, what are you guessing? How do we classify this? I got some reals and some imaginaries. 4 reals minus 7 imaginaries. That would be classified as complex. Okay, what about 3/5? What are we going to say 3/5 is? It's a fraction, so it can be expressed as a quotient. It's simplified. 3 cannot be divided by 5, so it is rational. If it's rational, what else is it? It's real. And now if it's real, we're saying it is also complex. Okay, what about a negative 10/3? What if you come across negative 10/3? What kind of number is negative 10/3? Negative 10/3. How come it's not irrational? What kind of numbers are the irrationals? They're the numbers that cannot be expressed as a fraction. They're decimals that go on forever with no pattern. So if you do negative 10 divided by 3, it's like 3.3333333. So it's a decimal that goes forever, but it's got a pattern. So this one is rational. If it's rational, it is real. And if it's real, it is complex. So this belongs to like 3 sets. Okay, this guy right here, type it in on your calculator. Everybody do 3 minus square root of negative 20. Dylan, what kind of number is this? So we just did it on a calculator. We just plugged in 3 minus the square root of a negative 20. If you got to guess what this is, what is it? It's got an imaginary part. This is your imaginary part. It was like this. It was 3 minus 3.4 blah 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 I. So that is the imaginary part. What's this part right here? So what if you got a real part and an imaginary part? What kind of number is this? It's just complex. This number is just straight complex. Okay, if you guess, Brooks, if you're going to guess where this number is, check out this number. So Brooks, what do you know about square root of 49? What's square root of 49? What? Brooks, what'd you say? I didn't hear you. There we go. So what is the square root of 49? If you take the square root, that is 7. What about the square root of 64? Square root of 64 is a perfect square, that's 8. So Cynthia, square root of 50 is a lot closer to square root of 49. So if you got to guess a number for square root of 50, what's your number? 7.2 or 3, 7.1. It's That's a good guess. Now, this is going to go on forever. 7.01 blah 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 plus 3 is going to be like 10.01 blah blah blah. What kind of number is this? How do we classify that number? It's irrational. So if it is irrational, what else is it? It is real. Irrational, real, and it is complex. Complex is everything. Any number is complex. Then if we start breaking it down to specific sets, punch this in on your calculator. What is the square root of negative 4? What does it say? 2i. What kind of number is 2i? It's imaginary. This is imaginary. If it is imaginary, what else is it? It's complex. So, they are all complex. Okay, now, hopefully it's starting to sink in a little bit. The real number line, you all know. So the real number line, let's plot all the reals. So your real number line, it's just the number line. We got 0 right in the dead center. So the real number line, this imaginary one, that does not show up. Okay, square root of 10. Where did we say square root of 10 was? Type it in your calculator. What's square root of 10? 3.1 blah 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 blah. Okay, so it is right here. 1, 2, 3. It's in between 3 and 4. So that's 3. Right here lives square root 10. Pretty close to the 3. Okay, we got that one done. The next one, 4 minus 7 imaginaries. Okay, if it's got an imaginary, it does not live on this real number line. Okay, 3/5. Type in 3/5 on your calculator. So we got 3/5 is 0.6. 0.6 is right here. 0.6 is somewhere between 0 and 1. So right there is 3/5. Okay, do this on your calculator. What's negative 10/3? Where does negative 10/3 live? Where we put negative 10/3? Negative 3 1/3. So go 1, 2, 3. So in between a negative 3 and a negative 4 lives negative 10/3. Okay, the 3 minus this, that has an imaginary part, so that does not live on the real line. This one does. 3 plus square root of 50. Punch that in. What's 3 plus square root of 50? 10.0, so just barely after 10. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Here's 10. There's 11. Right there after 10 is 3 plus square root 50. Okay. So to figure out where they go on the number line, probably approximate them to a decimal, and that's the easiest way to find them. Okay, the complex number plane. The complex number plane is way cool. So here's how it looks. You are going to have an x-axis and a y-axis. Now the x number line is where we're going to put all the reals, and the y number line is where we're going to put all the imaginaries. So all the reals go here. So this first one, if you've got to plot 3 imaginaries, 3 imaginaries has no real part. It's only imaginary. So it's going to be on the imaginary line. So let's go 1, 2, 3. Right there is where 3 imaginary live. Okay, we did square root 10. Square root 10 was somewhere between 3 and 4, and that's real. So 1, 2, 3, 4. So right here, that's like square root 10. Okay, now this part, McKenna. Let's do this complex. Let's do 4 minus 7 imaginaries. Where does 4 minus 7 imaginaries end up? You gotta guess, McKinnon. Where are you guessing? So do your real part. So go over 4. So go 1, 2, 3, 4. But then you got to do your imaginary part. So it's going to end up in quadrant 4. So if you go right 4, but then it's a negative 7 imaginary, so now you got to go down 1, 2, 3, 4, 5, 6, 7. So it ends up like right here. This point is the point 4 reals minus 7 imaginaries. Ends up clear in the middle of quadrant 4. Okay, let's skip this. 3/5 and negative 10/3. 3/5 was somewhere between 0 and 1 right there. Negative 10/3 was negative 3 1/3. So like right here is negative 10/3. But let's do this one. Jackson. Where does this live? 3 minus the square root of a negative 20. Which quadrant? Quadrant right here, bottom left. Quadrant 3. What number was that on our calculator? So it's this guy right here. It was 3 and then a negative 4.5 imaginaries. So to do that, we gotta go over 3. 1, 2, 3, and then down 4. 1, 2, 3, 4. So it lives right. It lives pretty close to 4 minus 7 imaginaries. This is 3 minus square root of negative 20. The 3 plus square root of 50, that was 10 something, so that's under my real number line. And then this guy, square root of a negative 4 is 2 imaginaries, and that lives really close to the 3 imaginaries. That lives right here. So there's 2 imaginaries. Okay. So we're in business. Let's start your homework. Now let me pass it out, and then let's draw something. Okay, on the back, let's draw a big box. Draw a big old box. Emily, after today you're going to be pro at classifying numbers. So we got a big box. Now, the title of the box is complex. So, all numbers are going to be complex. There are 2 types of complex numbers. What are the 2 types of complex numbers? Real and imaginary. So, the reals make up most of them. So let's come over like 2/3 and let's draw. Okay, here live all the imaginaries. Imaginaries are easy to spot. Imaginaries always have an I at the end of them. Like 2 imaginary. Or you could have 10/3 imaginary. Any number that can be real, you just slap an I on it and it makes it imaginary. So you can have square root of 10 imaginary. Okay, these are also imaginary. Any time that you take a number and you have an even amount and your outcome has to be negative, That is the definition of an imaginary. So if you start undoing this square, if you have the square root of a negative, that is imaginary. So square root of a negative 4 is imaginary, square root of a negative 16 is imaginary, square root of a negative 10 is imaginary. Anytime you got a negative under a square root, it's imaginary. Okay, the reals. Let's talk about the reals. The reals we're starting to get pretty good at. The reals, there's two types of reals. What are the two types of reals? Yes. Rational versus irrational. So if it's real, it's going to be one of the two groups. It's either going to be rational or it's going to be irrational. Okay, now irrational. I'm going to cut that again. Okay, here are the irrationals. Irrational is a decimal that cannot be written as a fraction. So they're decimals that go on forever. They have no pattern, they're chaotic, they're random. So it's a never-ending decimal that has no pattern. You cannot write them as a fraction. Okay, the rationals. Talk to me about the rationals. What's the very first set of rational numbers? What was the n? The naturals. Okay, the naturals. They are 1, 2, 3, all the way to infinity. So these are the first type of rational number. So the rationals are all the normal, logical, they behave well, play well. After the naturals, what was the W? So the wholes come along, and the wholes include all the naturals, but they have 0. Then mathematics evolves and we introduce a set of numbers, the integers. And what do the integers have that the wholes and the naturals do not? They have all these negatives. So the integers, they go to negative infinity, but they also go to positive infinity. So they include all the wholes, all the naturals. What is unique to them is they have negatives. Okay, then after the integers we introduce what is unique to the rationals. What can you find in the rationals that you cannot find in the integers? The fractions, the decimals that can be written as fractions, so like this. So the rationals, they include all this: negative 2, negative 1.5, negative 1, 0, 1.33 forever. If you can write that decimal as a fraction, it's rational. 2. So the rationals have a bunch of decimals, but they're normal decimals. You can write them as fractions. Okay, now go back to your notes. Go back to this part right here. Okay, look at this. This is a big deal. This a plus bi, this is how we're going to express all our answers. You put the real part first, and you put the imaginary part second. So the a is referring to the part that is real, and the bi is referring to a part that is imaginary. So let's go through these 3 bullets and we'll call it good. So bullet number 1. What if you come across an answer where your B is 0? So it would look like this. Example. So after all my calculations, I have like 4 plus 0i. So my A would be 4 and my B would be 0. So when your B is 0, what kind of a number is this? It is a whole number. It's just 100% real. So if I got 4 reals and 0 imaginaries, your answer is straight up real. Let's look at bullet 2. If b is not equal to 0, so an example for that would be this. What if I did my calculations, I had like 4 plus 4i. So what if I had 4 reals and 4 imaginaries? Samantha, what kind of number is this? If your b is not 0. If I got like 4 reals and 4 imaginaries. Man, it's complex. It's complex. And it's going to be some type of imaginary. If I have real and imaginary, some type of imaginary. Okay, it is going to be complex. What about the bottom one? What if a is 0? So what if I had like this? What if I had 0 plus 4 imaginaries? So I had no reals and I had 4 imaginaries. It's still complex, but this one is, if you have no reals and you have all imaginaries, then it's a pure imaginary. So you're not mixing with any reals. It's going to be pure imaginary, and it is complex. Okay, let's start on your homework. Get it done, hand it in. We're going to check it before you leave.